Okay, page 298, question number 1. Pile driver drops a mass of 550 kilograms from a height of 12.5 meters above the ground onto the top of the pile 2.3 meters above ground. Relative to ground level, what is the gravitational potential energy of the mass? So let's take a look at our diagram. We have our mass up in the air, we have our pile down here. Now it tells us relative to the ground, so our ground is 0 height. We know up to the top of the pile is 2.30 meters. Up to the top of our mass is 12.5 meters, and our mass is 550 kilograms. So now I can take a look at the different parts. Part A, at the highest point. So part A, our gravitational potential energy will be mgh. So our mass is 550 kilograms times g, 9.81 meters per second squared, and our height is 12.5 meters. So I plug that into the calculator. We have 550 times 9.81 times 12.5 gives me 67443.75 joules. 3 significant digits, so we keep the 674 times 10 to the power of 1, 2, 3, 4 joules. And that matches what we have in the book. Part B asks us, what is the gravitational potential energy at the lowest point? So the lowest point is when the mass has hit the pile and it's only 2.3 meters above the ground. So same equation, mass times gravity times height. Our mass is 550 kilograms, g is 9.81, and our height is 2.30 meters. So putting that into the calculator, 550 times 9.81 times 2.3. Helps when you type it in right. There we go. We got 12409.65 joules. So that's going to be 1.24 times 10 to the power of 1234 joules. And that matches what we have in the book. Now, part C says, what is the change in gravitational potential energy of the mass as it's lifted from the top of the pile to the highest point? So going from here to here. Now, we have the energy at the top and we have the energy at the bottom. So there's 2 ways of doing this question. We can see that the change in energy is the final energy minus the initial energy. If we do that, we take our final energy minus our initial energy. So 6.74 times 10 to the power of 4 minus 1.24 times 10 to the power of 4. So 6.74 times 10 to the power of 4 minus 1.24 times 10 to the power of 4 gives us a value of 55000 joules. So 5.50 times 10 to the power of 1, 2, 3, 4 joules of energy. Now, the other way we can do this is E equals mgh. So 550 times 9.81 times the change in height. So now we have 12.5 minus 2.3. We should get the same answer. So grab my calculator, 550 times 9.81 times brackets 12.5 minus 2.3, close brackets, equals, and we get 55034.1 joules. So obviously small rounding difference, and we get 5.50 times 10 to the power of 4 joules for both methods. Good.